Ladies and gentlemen, boys and girls, welcome to another video. Today we are rocking with long division. Huge shout out to all my 4th and 5th graders tuning in online and all the ones that go to the greatest school in the universe. You know what it is. Drop a beat. I said drop a beat. All right. So this video will be under the November Lives playlist, and it is a review of the long division that is currently being taught in 5th grade. So I'm going to walk you through step by step how to solve these long division problems. Now, it is actually very easy if you're able to divide single-digit numbers. If you're able to divide one-digit numbers, this is easy. If you're having a little trouble with one-digit numbers, it's still fairly easy. It's a little more challenging if you're not able to divide one-digit numbers fluently, but if you're not there yet, don't get discouraged, because I have a strategy that will help even if you're not fluent in division yet. All right. So 644 divided by 2. So what we're going to do is we're going to start with the smallest number possible. We're going to look to see if we can divide the smallest digit possible within the box here. So we're going to look at the digit all the way to the left. As long as the digit is bigger on the inside, is bigger than the digit on the outside, we can divide. So 6 is bigger than 2, so we're going to start off by doing 2 divided by 6. So this will make it easier to start here. So we are not worried about the other two numbers. Even though we're ultimately going to divide 644 by 2, we are going to start out only worrying about the 6 right here. 6 divided by 2. So we have to figure out how many times 2 goes into 6. So if you're not able to do that in your head, what you can do, you can draw 6 tallies. 1, 2, 3, 4, 5, 6. And you can draw a circle around every 2 tallies and see how many circles that you come up with. So I'm going to draw a circle around the first 2 tallies. I'm going to draw another circle around the second 2 tallies. And I'm going to draw a third circle around the last 2 tallies. So how many circles did we come up with? I just took my 6 tallies and I divided them into groups of 2. How many circles do I have? How many groups of 2 do I have? 1, 2, 3. All right, so 6 divided by 2 equals 3. 2 goes into 6 3 times. Now what I'm going to do is I'm going to count the number of tallies within the circles. Sometimes there is a number outside. There are more tallies outside of the circles. If you were a remainder, you're going to see more tallies outside the circles. But for this problem, I don't believe there is a remainder. So I'm going to count up the total number of tallies now. 1, 2, 3, 4, 5, 6. That does not change. So 6 minus 6 equals 0. So 6 divided by 2 equals 3. There's no remainder. So now we got to bring down the next number. So the next number is a 4. So we're going to bring down the 4 here. Now we have to figure out how many times 2 goes into 4. 4 divided by 2. So pretty simple math here. I'm going to make 4 tallies. 1, 2, 3, 4. Every 2 tallies, I'm going to draw a circle around. So there's a circle around those 2 tallies. Another circle around these 2 tallies. How many groups of 2 do I have within the number 4? Let's see. 1, 2. So I was able to come up with 2 circles, 2 groups of 2. 4 divided by 2 equals 2. Now I'm going to count the total number of tallies. 1, 2, 3, 4. Total number of tallies within the circles is 4. So here we go. 4 minus 4 equals 0. All right, now the final number. I have to bring the final number down. So we're bringing down the final 4 over here. 2 goes into 4, so same thing. 4 tallies. I'm going to draw a circle around every 2 tallies. Was able to come up with 2 groups of 2. 4 divided by 2 equals 2. One, two, three, four total tallies in the circle. And our answer is 322. All right, now I am going to do another one. All right, so I'm going to leave this up for anybody who wants to take the notes, copy it down, and leave it up for another 8 seconds. Also, feel free to pause the video if you want to copy this down or take the notes. Feel free to pause it at any time. All right, next problem. I want to do one where there's a remainder so you guys can see. All right, 5,000 divided by, or 5,000. I misspoke. 660 divided by 5 is going to be the next problem. So we have 660 divided by 5. So now this one is going to have a remainder, but steps are the same, pretty much. All right, so we're looking. I'm going to start dividing with the smallest digit possible. So 6 is bigger than 5, so we can actually start dividing with a single digit number there. All right, so 6 divided by 5. So what I'm going to do is I'm going to make 6 tallies, and I'm going to draw a circle around every 5 tallies. Now, there is going to be a remainder for this one. So pay attention. So I'm going to draw 6 tallies now. 1, 2, 3, 4, 5, 6. Now, around every 5 tallies, I'm going to draw a circle. So 1, 2, 3, 4, 5. So there is 5 goes into 6 one time. There is one group of 5 within 6. If I did another group of 5, we would have 10 total tallies. We would be beyond 6, so it wouldn't work. We can only get one group of 5 before we pass the number 6 here. So 6 divided by 5 equals 1. Now I'm going to count the total number of tallies within the circle. I'm only going to count the number of tallies within the circle. The one that's outside of the circle, I'm not even counting that. All right. I'm not counting the one outside the circle, but I'm going to count the number of tallies within the circle. 1, 2, 3, 4, 5. So there are 5 tallies within the circle. So I'm going to subtract 6 minus 5 to figure out what the remainder is. We kind of already know what the remainder is because it's one tally outside the circle, but still I'm going to continue with the math there. So 6 minus 5 equals 1. So 6 divided by 5 is 1, and we have a remainder of 1. All right. So now we're going to bring down the next number. I'm going to bring down the 6. So now we have 16 divided by 5. So I am going to draw 16 total tallies. I can make them in rows of 5, or I'll make them across. I'll make them in rows of 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right. Now, every 5 tallies, I'm going to draw a circle around. We have to figure out how many circles how many groups of 5 we can get within the number of 16. So I'm going to draw one circle around the first row of 5. I'm going to draw a second circle around the second row of 5. And then around the third row of 5, I am going to draw a third circle. You know what I'm going to, and I'm going to separate that a little bit. All right. Now, how many circles do we have? How many groups of 5 do we have? 1, 2, 3. So 16 divided by 5 equals 3. 5 goes into 16 3 times. Now, to figure out the remainder, even though by the picture we already kind of know what the remainder is, I mean, I'm going to go through the steps. I'm going to count how many total tallies within the circles there are. I'm not going to count the tally outside of the circle. I'm going to count just the tallies that are inside a circle. How many tallies do we have within the circle here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So to figure out the remainder, you would do 16 minus 15. Now, if you're able to skip count, this does go faster. I counted one by one, and I counted the 15 tallies, which is, there's nothing wrong with doing it that way, but the quicker way would be to just count by 5s. 5, 10, 15. All right. So now I have 16 minus 15. 6 minus 5 is 1. 1 minus 1 is 0. All right. So I have a remainder of 1. 16 divided by 5 is 3 with a remainder of 1. So now I have the very last digit that I need to bring down here. So I'm going to draw an arrow. I'm going to put a 0 next to this 1. And the number is 10. So I have to figure out how many times 5 goes into the number 10. 10 divided by 5. So I am going to draw 10 tallies. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Every 5 tallies, I'm going to draw a circle around. I'm going to figure out how many total circles I have. How many circles I have. So 1, 2, 3, 4, 5. That's one group of 5. 1, 2, 3, 4, 5. That's 2 groups of 5. All right, so I have 2 circles, 2 groups of 5. 5 goes into 10 twice. Now, how many total tallies do I have within the circles? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 minus 10 equals 0, so there is no remainder. 660 divided by 5 equals 132. All right, so we have our answers. And as always, I am going to end the video by playing some basketball. Healthy body, healthy mind. So let me move the camera over here. Now, I don't want to overdo it or put too much wear and tear on my knees. I did squat this morning, so I'm not going to do a whole lot of dunking today. I'm going to do some turnaround jumpers. When you're old and over the hill and can't jump as much, if you know how to shoot, if you have good footwork, that can make up for a lot. You could completely lose your vertical leap, but if you have the shooter's touch and you know how to free up space and you have good footwork, you can still drop 20. Kareem could barely move in his final year of basketball, but his footwork and his sky hook was so elite, so unstoppable that he still was able to be effective. So I'm going to grab the basketball and we are going to get to it. All right. So I'm going to start off with some turnaround jumpers here. All right. So I'm going to post up and catch the ball in the post. Turn to the right, shoot, 5 on each side. All right, we ready? All right. Off the mark. We move it off the mark. Second shot. All right, there's one. Two for three so far. Two more shots. Two more shots. Two more shots. Four. One more. Five. All right, other way now. Other way. Going right. Going right. He's not giving me this side. I got to go the other way. Wow, I couldn't drain the bathtub with that shot. It's all right, though. 1 for 2. Two for 3. Two out of 4. Three out of 5. 7 out of 10 so far overall. Not too bad. All right, perimeter shots. I'm going to catch and shoot off the perimeter now. 5 off the perimeter, and then I'll end it with a dunk. One dunk to end it. All right. One for 1. 1 for 2. 2 for 3. 2 for 4. 3 out of 5. Other side now. Other side. Other side. Different angle here. Different angle. Oh for 1. I could not drain the bathtub with that shot. Here we go. There's another shot though. 0 for 2. I gotta at least make 3. I'm gonna take more shots if I don't make at least 3. 0 for 3. Not my spot. 0 for 4. I might as well just go 0 for 5 and take another 5 and not count that because I gotta at least make some. 1 for 5. There we go. All right. I'm gonna keep shooting until I make at least 3 more shots. 3 more shots, and then I'm gonna end it with a dunk. All right, here we go. That's 1 make, 2 makes. There we go. I found the stroke now. There we go. All right. Let's see if I can still get above the rim here. A couple layups, then I'm going to dunk it. Windmill. Woo! I still got it. For all these years, I can still get above the rim. All right. The final dunk of the night. Here we go. Woo! That's what. Well, that's not the final dunk. I want to go other side too. Other side too. All right, that is my video for today. Please leave a comment. Let me know if this was helpful. Let me know how you feel about long division. If you're still confused, if you have any questions, please write that in the comments. And if there's another problem, something else you're working on in math or reading that you're having difficulty with, write an example of something that you're having a hard time with in the comments as well, and I will do a future video on that concept or that topic. Have a great rest of the day, and I will see you tomorrow.